Okay, let's start. So we will be having a discussion about relation, but before that, let's take a brief discussion about sets. So set, already you have learned the concept of set in class 11. Here I'll be taking a brief discussion about that, and then we'll be moving towards the relations. So the first thing you need to know about set is how to represent the set. We are having two different types. By using those type, we just represent the set, that is set builder form and roster form. So if we are having one of the example, let's say we are having a set A. Just a moment, let's take a set A. The element of set A, we can take it as 4, 5, 6, 7, 8, 9. This is the roster form of representing the set. Okay, this set is already in roster form. The elements of set are 4, 5, 6, 7, 8, and 9. How we write it in set builder form? So we can write it in set builder form, that is A. There is a set A which is having, set A consists of all element x, such that now we have to see what the pattern is going on. Here we are having 4, 5, 6, 7, 8, 9. I can see natural numbers are there, but that natural number is having restriction. It is less than 10, we can say, or more than 3. So we can say x is a set of natural number, or we can also write x belongs to n, natural number. And also we have to write the condition, that is x greater than 3, less than 10. In a very simple way I have written this condition: x is greater than 3 and less than 10. This is called the representation of set in set builder form. Okay, now the next concept is types of set. We also need to know the types of sets. That is, the first type, we are having empty set. As the name suggests, like here the name is saying all about itself, empty set. That means nothing is there, the set is empty. Or we can also represent it by using 5. So there are two ways to represent empty set, either the first one or the second one. Now the example of empty set we can take as set of students who are studying in class 9, class 10 as well, class 11 as well. Okay, set of students who are studying in class 10 and class 11. So this is not possible that one student, like one single student is just that student is in class 10 also, and that particular student is in class 11 also. So we can say this will be empty set. Okay, that is impossible. Now the next set we are having over here is equal set. Now equal set, we need to know, if we are having a set A, the element of set A is 1, 3, 5, 7. And let's say we are having one more set, that is set B. And the element of set B is, let's say, 5, 7, 3, 1. So set A and set B both are equal set. Here the arrangement of the element doesn't matter. We are only going to check whether the element, this one, is there in set B also or not. If A is having an element as a 3, set B is also having the same element or not. This is how we will be just matching. And if each and every element of set A is already there in set B, then we can say set A is equals to set B. Again, I would repeat, the arrangement doesn't matter over here. Okay. Next we are having finite and infinite set. Now only whatever examples I have taken, set A, set B, and the first example also, set A is having 4, 5, 6, 7, 8, 9. These are finite set. The name finite, that means number of element has to be finite. So these are the example of finite set. Now what about infinite set? The set we always use, set of natural number, set of real number, set of rational number. These are infinite sets. Okay, because there are infinite numbers of element in these sets. Okay, now let's move to the next concept over here. So the next concept we are having here is power set. Yeah, before that we need to know, you need to know the concept related to subsets. So we will be coming to power set, but before that, let's take what exactly is subset of any set. So we can take one example, that is if we are having set A is equals to, let's say the number are 1, 2, 3, 4, 5, 6, okay? And if we are having set B, let's say 2 and 4, then we can say B contained in A, okay? B, the element of B, 2 and 4 is already there in set A. So we can say B contained in A, or we can also say that B is the subset. B is the subset of set A, okay? Now, one example over here will be, yeah, let's take the concept of power set, that we will be just relating the concept over here. Power set. So far, whatever we have discussed, a quick discussion related to all this topic, which is already known to you. Is there any confusion over here?
No, ma'am.
So power set. Now, suppose we are having set A, that is 1, 2. Okay, the element of set A is 1 and 2. Now, we can write all the possible subset of A. All the possible subset of A, how we'll be writing? So 5, first subset will be 5. Now only we will be having a discussion about that. Now the next subset of A will be 1. After that, the next subset over here will be 2. Okay, and one more subset will be there, that is 1 and 2. So this phi is empty set. Empty set is subset of all the sets. Okay, whatever be the set, we will say that empty set is its subset. Okay, because empty set doesn't contain anything. So always we will start with empty set, and empty set is a subset of all the sets. Now here we are having element 1. So if let's say any other set is there, let's say set B is there and having just one element, that is 1, so obviously B is a subset of A. If let's say there is a set C and having an element 2, so we can see C contained in A. The element of C is already there in element of A. Okay, already there in the set A, I would say. Okay, so C is the subset of A. Similarly, every subset is a subset of itself. Let me write it. Every set is subset of itself. So our set A is 1, like this is the set we are having, and the element of set A is 1 comma 2. If we are having one more set, let's say X, that is also having 1 and 2. So we would say that A and X both are same, or we can also say that X is a subset of A. Okay, are you getting it?
Yes, ma'am.
So the collection of all the subset of any set is called power set. Okay, collection of all the subsets. How many subsets we have got? 1, 2, 3, 4. 4 subsets we have got. Let's see carefully. When the set A was having 2 elements, then how many subsets we have got? 4 subsets. A is having number of element. This is how we represent the number of element of any set. And in bracket A means number of element in set A is 2. How many possible subsets we have got? So 4 subsets, total 4 subsets we have got. You can see here carefully, 4 subsets we are having, 1, 2, 3 and 4. Now there is a formula related to that. When we know the number of element, then we can just write it as a power of 2, and that will give us the total number of subsets. That is 4 subset. This 4 came from here. And what is this 2? This 2 is the power 2. Okay, let me clear it. If the number of element in a set B is 3, then total number of subsets it will make will be 2 to the power 3, that is 8. Okay, if the number of element of a set C is M, then total number of subsets it will generate is 2 to the power M. So this 2 which is there in the base, that is constant. We are using the number of element to write the power. Okay, and that is giving us the total number of subsets. So we write it like this. We write it like this. We write power set of A is having elements 5, this 1, 2, 1 and 2. Okay, this is the set of, like, power set is having these elements. Now the number of element in power set is 4. How it came? When we are just raising the power of 2, when we are writing in the power of 2, when we are writing the number of element of the original set, that is giving us the number of element in the power set. Okay, similarly, number of element in the power set of B is 2 to the power 3, since the number of element in B was 3. Similarly, number of element over here, for the power set we are getting the number of element as 2 to the power M. Now let's take one question from here which is related to this concept. This one is very basic concept, and yes, on this very basic concept we are having one question, okay, from JEE. And that too in 2020 previous year question. So let me take the question. Set A has M elements and set B has N elements. If the total number of subsets of A is 112 more than the total number of subsets of B, then the value of the value of M minus N we have to find. Option A, just a second. Option A 32, option B 28, option C 39, option D none of this. Okay, let's see how can we do it. So here we are having a set A. How many elements are there? Number of element in set A is M elements are there. Okay, let me write it. How we represent it? And number of element in set A. How many elements are there? M elements are there. M. And number of elements, set B has N elements. So number of element in set B is equals to N elements. Okay. If the total number of subsets of A is 112 more than the total number of subsets of B. That means here A minus B is given as a 112. like number of element in set A, number of element in set B, total number of element of the subset. Let's see. Let's just give a careful observation on this statement. If the total number of subsets of A, total number of subsets of A, that means it is talking about the power set. Yes or no?
Yes, ma'am.
Okay. Total number of subset. Now only we have had the discussion that total number of total subset, and that we have written as a power set. Okay, so total number of subset means power set. So if the total number of subset of A is 112 more than total number of subset of B. Okay, 112 is something we will be thinking about it, but at first it is talking about the total number of subset of A and the total number of subset of B. That means it is talking about the power set of A and the power set of B. Okay, so it is talking about the power set, that is n of PA, and it is also talking about n of PB. Okay, and then we have to frame a equation where it is saying that total number of subset of A is 112 more than, like my age is 20 years more than your age or something. How we usually just write the equation? Very simple equation we will be able to frame, but first we need to write the power set. Let's write the number of element in the power set of A will be 2 to the power
Power
n.
set means all the subsets are there.
Yeah, all the subsets are there.
Okay.
So number of element in the power set of A will be 2 to the power m. Yes or no?
Yes, so ma'am, the difference is 112.
Yeah, difference will be 112. And number of element in the power set of B will be 2 to the power n. That's what we have learned now. How to write the number of element of the power set to 2 raised to the power, whatever be the number of element A is having. If A is having m element, then 2 raised to the power m. That much subsets we will be able to generate from the set A. Okay, and that's called power set. Am I making sense to all of you?
Yes, ma'am.
Let's move ahead. Now, here the given condition says that A is 112 more than B. That means we can write number of element in the power set of A minus number of element in the power set of B is equals to 112. A is more, so whoever is more, that we need to mention at first. If my age is more than your age, then we will do the subtraction by writing my age at first and then your age. Okay, this is how we frame the equation. Don't get confused between which one is more, which one is less, how to frame the equation. Just we have to write the difference between both as a 112, but A is more, so A I am writing at first. Now let's write this one we have written as a 2 to the power m, and this one we have written as a 2 to the power n is equals to 112. Now this 112, let's do the factorization. Here we are having 2 raised to the power something. Here we are having 2 raised to the power something. So if I will ask class 9 or class 10 student, they will say, okay, ma'am, let's do here also on the right hand side also 2 raised to the power something. If that is possible, so let's do the factorization. So 112, when we will do the factorization, to 5 times 10, to 6 times 12, to 2 times 4, 8 times 16, to 1, 14, then 2, 7 times. So we got 2 into 2 into 2 into 2. That means we got 2 to the power 4, but we got 7 also over here. Here we got 2 to the power m minus 2 to the power n is equals to 2 to the power 4 into 7. Okay, now what we will be doing here, this 7 is there. What we are supposed to find? We are supposed to find m minus n. So m minus m, if we will take common 2 to the power n over here, then we will be able to write it as a m minus n. Yes or no? Are you getting it?
Can you
Let
say
me break
again?
it.
Yes, ma'am.
Okay, let me break it. Let me write one more step so that you will be able to understand how I am writing. Or before that, yes, first let's make m minus n over here. Or we can also start with 2 to the power 4, and this 7 we can write it as a 8 minus 1. Okay, why 8 only? Why not any other number, 9 minus something? Why not 10 minus something? Why not any other number minus something?
2 raised to
So
3.
yes, we are focused on 2 to the power something, 2 raised to the power something. That's why I am writing 8 over here. So we can write it as a 2 to the power 4, and 8 we can write as a 2 to the power 3 minus 1. Now on the other side also we need to make the same pattern so that we can do the comparison of the powers on the both side. So let's make the same pattern. So here, if we will take 2 to the power n common. So if you are confused from here how we will be having 2 to the power n as a common, so we are just thinking like that, 2 to the power m into 2 to the power n by 2 to the power n. This is what we are thinking about the first term, and we are taking 2 to the power n common, so we are left with 2 to the power m by 2 to the power n minus 1. That means we are left with 2 to the power m minus n minus 1. Is it clear so far?
Yes, I know it's clear.
Clear, ma'am.
Yes, anyone said that is not clear?
It's clear.
It's
It's
clear.
clear, ma'am.
Okay. So now we can say this, we can do the comparison of the power. That's what we do always. So we can say this n and this 4 will be equal. And we can also say this m minus n and this 3 will be equal. So we got two equations over here. We got that by comparing powers of 2 on both sides, we got n is equals to 4, and we also got m minus n is equals to 3. What we are supposed to find? Are we supposed to find m? Let's see. We have to find m minus n. Okay. Let me check the question now. It's not m minus n, it's m into n. A very slight dot is there, which I missed over there. It's m into n, okay? So accordingly, options are given over here. So yes, we need to find m also. So n is 4, so m will be m minus 4 is equals to 3, so m will be 7. And if we have to
28.
find the product of the two, that means 7 into 4, that means 28. 28 is the right option. This one is the right option. Okay. So just by using the concept of power set, basic concept, we are able to do this question which was there in 2020. Okay, let's move ahead. Now we will be having a quick discussion related to the Venn diagram and universal set, and then we will start the concept of relations. Okay, so universal set, what does it mean? Universal set. So if I am saying there is a set of a student of class 12. For this set, what is the universal set? So we can say set of student of class 12 of obviously a particular school. So for this universal set, we can say it will be the set of all the student of the school. That will be universal set for the given set. Okay. So if this concept of universal set, what exactly is universal set, or if this one is clear, let's see the Venn diagram where we will be having the universal set A, set two different set, not only A and B, it can be X and Y also, or two different set. Let's see the operations related to that. So we are having Venn diagram and we will be having the discussion related to operations. Okay. So union of two set. If there is a set 1, 2, 3, 4, 5, and if there is a set B that is 5, 6, 7, then what will be the union of these two sets? Let me know quickly. Anyone? What will be the union of
Okay,
these
let's
two
say.
sets?
1, 2, 3, 4, 5, 6, 7.
Exactly. Union means all the elements will be there. The element of set A, the element of set B, whatever is common, that will be taking one time, and rest of all the term will be taking over here when we are writing the union. And the Venn diagram for union is, if these two sets are there, union of A and B will be everything over here. What about the intersection? The intersection means only the common part, the common reason. So here we can see the common element is 5 over here and 5. So we can say 5 is the common element, and this is the intersection of A and B. Now sometime it can happen that there is nothing common in between A and B. If let's say A is the same set and we are having set C as a 9, 10. Intersection of A and C is what? Nothing. So it will be 5. And what about the Venn diagram? So Venn diagram will be like this. A and C is nothing common in between. Okay. And that's called disjoint set. Okay. Disjoint. See the word, not joint, nothing common. Okay. Disjoint, when two sets are disjoint set, there is nothing common, intersection will be 5. Okay. Now the next operation, that is difference of set. So difference, when we are having set A, let's say 1, 2, 3, 4, 5, 6, 7. And when we are having another set B, let's say 6, 7, 8, 9. Then A minus B, whenever we are finding A minus B, we will be writing the element of set A which is not there in B. Element of set, all the element we will be writing over here of set A, but that element must not be in set B. Let me write 1, 2, 3, 4, 5, but that's it. Okay. 6, 7 we will not be taking over here because that is in B also. Can you see? So A minus B, the Venn diagram will be like this. Let's say this one is set A, this one is set B. So only the element of B. Common part also we will not be taking, and B definitely we are not going to take. Now what about B minus A? B minus A means all the element of B that is not there in set A. So if here only we have to find B minus A, we will be having 6 is there in set A, we cannot take. 7 is there in set A, we cannot take. 8 and 9 we can take. So element of set B which is not there in A. Is it clear?
Yes, ma'am.
Let's move
Yes,
ahead.
ma'am.
Ma'am. Ma'am.
Yeah, are you saying anything?
Like removing the like the elements present in set B, we are removing the elements which are not there in set A, right?
Can you please repeat?
Ma'am, like B minus A means the removing the elements which are not there in set B, right? From which are not there in set A.
Yeah, B minus A means all the element of B, but those element which is there in A we cannot take. So
Okay.
element of set B which is not there in A. Yes, correct. Let's move ahead. So complement of set. Complement of set A, we represent it A dash like this. And what's the meaning of that? Suppose we are having a universal set. Now we need the universal set. Then only we'll be able to find complement of A. So let's say the universal set is 1, 2, 3, 4, 5, 6, 7, 8 like that. And if we are having set A as 1, 2, 5, 6, then complement of A, when we are writing, then we will write all the element from the universal set, but those element must not be there in set A. Okay, so let me write the answer, then you will be able to understand. 1 is there in A, I will not write 1. 2 is there in A, we are not going to write 2. 3, we will be writing. 4, we will be writing. 5 is there, 6 is there, we will not be writing. 7, we will be writing, and 8, we will be writing. That means complement of set A means universal set minus A. All the element of universal set which is not there in A. The Venn diagram of complement of A will be, let's say we are having set A having element 1, 2, 5, 6, and the universal set is having 3, 4, 7, 8. Yeah, like this. Then we can see universal set means this rectangular box is having everything. This rectangular box is having 1, 2, 3, 4, 5, 6, 7, 8. This rectangular box is called universal set. It is having everything inside it. You can see it is having 1, 2, 3, 4, 5, 6, 7, 8. Everything is there inside the rectangle, inside the rectangular box. That's called universal set. Now from there, this one is A. So when we are writing A complement, that means element of A, we will not be taking the element of A. That's it. Okay, let's move ahead. If anywhere you feel any doubt, please let me know. I will take a pause over there and will make it clear for you. Now few rules are there. Okay, we have already learned this. You have already learned this rule in class 11. These are the quick recap of that. Okay, so we are having rules. Practical problem we will be solving by using this rule on union and intersection. So the first rule is an A union B is equals to number of element in set A plus number of element in set B minus number of element in set A intersection B. In general, when we will be using this rule, if A and B are not disjoint. Disjoint means there is nothing common. A intersection B is 5. So if that is not the case, then we will be using this rule. And if A intersection B is 5, then the same rule will get converted into A union B will become number of element in set A plus number of element in set B. So the same rule, this rule only, we will be using like this when A intersection B is 5. What is the meaning of A intersection B is equals to 5? That means nothing is common over there. Okay. Now one more rule is there, that is A union B union C is equals to number of element of set A plus number of element of set B plus number of element of set C minus A intersection B minus number of element B intersection C minus and A intersection C plus number of element of A intersection B intersection C. These are the three rules we are having. If you understand the Venn diagram very well, then you will be able to relate with that. Then when we are having A union B, obviously it will be, we are taking the total number of element of B. We are taking the total number of element of C. That means twice we are taking the common reason. Are you able to visualize when we are writing this rule?
Yes, sir.
That's why one time we have to subtract the common part. And that's from there only this rule came out. And from there only the last rule also came out. That when we are having A, B, C, three sets, and when we are taking the number of element of the first set, number of element of the second set, number of element of the third set, that means we have taken everything. And thrice we have taken, like the common region we have taken three times, that we need to subtract. Okay, that's what we are subtracting, and then at last adding only the one common reason, that is the intersection B intersection C. Now let's just this basic rule which you already know. On this rule only we are having a question. Let me take that question.
I'm gonna scroll up.
Yeah, sure. Let me know once you are done.
Done.
Let's move ahead. In a class of 140 students numbered 1 to 140, all even numbered students opted mathematics course. Those whose number is divisible by 3 opted physics course, and those whose number is divisible by 5 opted chemistry. Then the number of student who did not opt for any of the 3 courses. This question is from 2019. Option A 42, B 102, C 38, and D 1. Let's see what exactly the question is talking about. In a class of 140 students, how many students are there? 140 students are there. Numbered 1 to 140. That means the roll numbers are 1, 2, 3, 4, 5, 6. Just like that, 140. All the even numbered student. All the even numbered students opted mathematics. From 1 to 140, whatever be the even numbered students are there, whoever be the student having roll number as a even number, those students opted for mathematics. Okay, those whose number is divisible by 3 opted physics, and those whose number is divisible by 5 opted for chemistry. Number of element in set A, set B, set C. 3 sets are there. One is the set of a student taking mathematics, another set of a student taking physics, another set of a student taking chemistry. Let's make the sets. Let's say an number of element of set A. Okay, A means number of student who are taking mathematics. Number of student of B, that means it's physics. And number of a student in C, that means chemistry. So number of a student in set A, all the student who are having even number as their roll number. So from 1 to 140, how many even numbers are there, that we need to know. Now there is a short trick for finding the even number, but before that, we can use the concept of AP. That is, first even number will be 2, second even number will be 4, third even number will be 6, and like that we are having the last number that is also even number as a 140. So we can use the formula of AP, that is nth term is equals to A plus n minus 1 into D. Nth term is the last term, 140 is the last term, A, that is 2 plus n minus 1, and D, the common difference is 2. Okay, when you will solve it, here we will shift 2, it will become 138 is equals to n minus 1 into 2. That means 2 we will send to this side, it will become 2.
70.
So you got n as a 70, right? N as a 70 you
Yes,
got.
ma'am.
Okay. So, and we got 70, but by using such a long process, we can use this way that 140 students are there. Number of a student having even number, that means divisible by 2. Let's see how many numbers are there which is divisible by 2. 70 numbers are there. Directly we will be getting. Okay. If you are getting a fractional number over here, so please take the nearest integer number. Okay. So the next one, divisible by, for physics, it must be divisible by 3 opted for physics. So 140
I can
divided
use
by,
GP, right?
yeah, what?
Can we use GP here?
GP, arithmetic progression. For the
Okay,
next
you
one,
take it.
for the next one,
No, ma'am. Sorry.
this one is the shortest, like shorter way to do the same thing. We will not be every
Okay.
time filming the AP and GP, whatever we are getting. We will not be just doing that. Quickly, we will see 140. From 1 to 140 is there. Straightforward numbers, natural number is there. So we can do 140 by 3. That we will divide. If we are getting a fraction, then again I would repeat, we will be taking the nearest integer. Whole number we will be taking, because we cannot say that 49.2 students are there.
46.
Okay, so 3, 4 times 12, 6 times 46. Next, 145. When it is divisible by 5, those student having their roll number divisible by 5, that student have taken chemistry. So 5,
28.
1 times 5, 5, 2 times 10, 5, 28, right? We got NA, we got NB, we got NC. What we have to find here, then the number of students who didn't opt for any of the 3 courses. So who have not opted for any of the 3 courses. That means total student, can we say it will be total number of student minus A union B union C who have taken all the subject. A union B union C means what? Number of element of A also, B also, C also, right? All together. So who didn't opt for any of the course, can we find it by doing total number of student minus number of student A union B union C who have taken maths, physics, chemistry, or any of the 2, because union is having any 2 also, right? Yes or no?
Yes, ma'am.
So number of students who have not opted for any of the course, we can find by doing total number of students minus n of A union B union C. Now only we have seen the formula for n A union B union C, that is n A n B n C, minus n A intersection B, B intersection C, C intersection A, and that then A intersection B intersection C. So we are having NA in our question. NA we have found, NB we have found, NC we have found 70, 28 or whatever. We have found that. But what about this NA intersection B? What about this NA B intersection C, A intersection C? That also easily we will able to find. Now, if we have to find N of A intersection B, that means the number which is divisible by 2 also and 3 also. So we can say the number which is divisible by 6. That will be 6 2 times 12, 6 3 times 18, right? Will it be 23? Check it. Are you getting how I have written 6 over here? I am saying the number which is divisible by 2 also and 3 also. So combining these two cases, we can say the number which is divisible by 6. Yes or no?
Yes, ma'am.
Yes, yeah.
Similarly, number of element B intersection C. Like that only we'll be finding the number which is divisible by 3 also, 5 also. That means 15. So 140 over 50. Okay, I am seeing this one and this one if you are getting confused. So it will be 15, 9 times 135 or what? Yeah. And number of a student A intersection B, B intersection C, and A intersection C also will be finding. So A is 2 and C is 5. That means 140 by 10. That means 40. Now what about N of A intersection B intersection C all together? Let's multiply divisible by 2 case, divisible by 3, divisible by 5. So 2 into 3, 6, 6 into 5, 30, right? So 140 divided by 30, it will be 3, 4 times 12, 4 point something. So we can take 4 only. Okay. As I said, we'll be taking the integer. Then let's use the formula, and A union B union C is equals to number of element of set A plus number of element of set B plus number of element of set C minus an A intersection B minus an B intersection C minus an C intersection A minus plus number of element A intersection B intersection C. Let's write all the numbers. We are having 70, 46, 28. So we are having here 70, 46, 28. Next 23, 14 minus 23 minus 14 minus 9 plus 4. Can you do the calculation quickly and let me know what are you getting? Total number of student is Let me know the calculation. 70 plus 46 plus 28 minus 23 minus 14 minus 9 plus 4. Let me know what exactly are you getting.
Two. 102.
Can you please repeat?
102.
Okay. Everyone, please check it. Are you getting the same number of a student who have not taken any course? Right? That's what we have to find. Then the number of a student who didn't opt for any course. Yeah. Number of student here didn't opt for any course. This is what we have discussed in the very beginning. We will be subtracting it from the total number of students. How many total number of students? 1 to 140. So 140 students are there. 102 we will be subtracting. 10 minus 2, 8. 3, 38 we are getting. Can you see option number C will be the correct option? Is it clear? Yes, we have done the calculation, but the concept was easy, right?
Yes, ma'am.
Yes,
Let's
ma'am.
move ahead. Now we will be starting with the concept of relations. So we are having one question. Now only you have given the exam of class 12. So relation and function you have done over there. So I'll be taking the question, and with the help of question, we will be discussing the concept over here. Okay, so the first question from relation is, let R1 and R2 be two relations defined as follows. R1 is given as set of all AB belongs to real number. R2R, that is A square plus B square, belongs to Q, that means rational number. R2 is equals to set of all AB belongs to R square. A square plus B square doesn't belongs to rational number, that means irrational number, where Q is the set of rational number. We know that Q is a rational number. Now the options are there like this. Option A is R1, R2, both transitive. Option number B is neither R1 nor R2 is transitive. Option number C is R1 is transitive, but R2 is not transitive. And option number D is R2 is transitive, but R1 is not. So here R1 and R2, two relations are defined over here, and we have to check which one is transitive. We don't have to check which one is reflexive, symmetric or not. Okay, we only have to focus on transitive. Why transitive? Because all the options are talking about transitive only, transitivity only. So let's see which one is transitive over here. We are having a relation R1, that is set of all AB. Again, this is set builder form. Okay, the representation of this relation is in set builder form. When we started learning the concept of relation, then we were having relation set R consists of ordered pair 2, 4, 4, 5, like that. That was the roster form. This one is the set builder form. Okay. So we are having this set relation R1, relation R2. Let's see what exactly the case of transitivity says. So AB belongs to R square, real number, where A square plus B square must be rational number. So if A square plus B square is a rational number, and transitivity, let's say BC holds, AB holds, AB belongs to R square, and let's say BC also belongs to R square, and following the same case, that is B square plus C square is also belongs to rational number. Now this is equation number 1 and this is equation number 2. By solving equation 1 and 2, by doing anything over here with the relation 1 and relation 2, not equation, relation 1, the first condition and the second condition, can we say that A square plus C square belongs to rational number? Let's add these two equations. So when we will add 1 and 2, we will be having A square plus B square plus again B square plus C square. That means we are getting A square plus 2B square plus C square. We know that will belongs to rational number, because rational number plus rational number will give us rational number only. But we cannot say that A square plus C square will belongs to rational number. Okay. So about transitivity, we cannot say anything over here. A square plus 2B square plus C square belongs to rational number. That is true. But only A square plus C square belongs to rational number. We are not sure about that. It is not transitive. Okay. Are you getting it?
Yes, ma'am.
Similarly, for the other case, same way, A square plus B square doesn't belongs to rational number. B square plus C square doesn't belongs to rational number. If we will add two irrationals, we will be getting irrational. We will add A square plus B square and that B square plus C square. All together we will add these two conditions. So we are getting A square plus 2B square plus C square, which is not rational. It's irrational. But we cannot say only a square plus c square will be irrational or what. That we are not sure about. So it is not transitive. First one also transitivity we are not able to prove. Second one also we are not able to prove the transitivity, and hence here which option is the correct option? So we can say option number B, neither R1 nor R2 is transitive. Is it clear?
Yes, ma'am.
Let's move ahead.
Yes, ma'am.
Now the next question we are having, the domain of the function f of x is equals to sine inverse 3x square plus x minus 1 over x minus 1 whole square plus cos inverse x minus 1 over x plus 1. We have to find the domain of it. Now the options are option A 0 to 1 by 4, B minus 2 to 0, union 1 by 4 to 1 by 2, option C 1 by 4 to 1 by 2, union 0, and option D 0 to 1 by 2. Once, when we are going to do this question, one thing you must know, that is the concept of wavy curve method. Are you aware of wavy curve method
No, ma'am.
for solving the inequality, for getting the intervals?
No, ma'am.
Let's take it quickly. Okay, that wavy curve method is not only useful for solving this question, it will be useful when we will be talking about the concept of function, when we will be talking about the for finding the range, domain, anything. Wavy curve method will always be useful. Let's see how to use that concept. So let me take examples. Quickly, we will be discussing the concept of wavy curve method, and then we will come over here, we'll solve our question. Okay, so whenever we are having equation like x minus 3 in one bracket and x minus 5 in another bracket, and if that inequality, not equation, inequality, if that inequality having greater than equals to 0, we have to find the range in which x will be lying. So how we will be finding that? We have to draw a real line, okay, minus infinity, which consists of negative infinity to positive infinity. Here we will be finding the zeros of the given inequality. Give only the right hand side we'll see, and we will see what are the critical point, what are the zeros. So x value over here I can see it's 3 and x value is 5. So we are getting two x value, one is 3, another is 5. Let's locate this one quickly, 3 and 5. Okay, now what we have to do from the right hand side, which one is the right side? This one is my left hand, this one is my right hand. From the right side, I will be starting placing the signs. Here I'll be writing plus sign, here minus sign, here plus sign. And what exactly this inequality says, that if you will focus on the inequality says that x minus 3 times x minus 5 must be greater than 0. That means the positive case we need to take from the number line. Now this one you have done by taking the test point. When we will be taking a test point in between minus infinity to 3, we will be taking a test point in between 3 to 5, and we will be checking whether our function is greater than 0 or less than 0. We will be taking the test point in between 5 to infinity, and we will be checking whether the function is greater than 0 or less than 0. Accordingly, we will put the sign plus, minus and all. But what I am saying, directly I am placing the sign over here, that is plus, minus, plus. From the right hand side, I am just starting with the plus. From right hand side, I have by myself, without looking at anything, I have written plus over there, then the other sign minus, and then plus. And I would say, since our equation is demanding about greater than 0, x minus 3, x minus 5 greater than 0, so we will be taking the positive case, and our interval will be here greater is there, equal sign is not there. That means here hollow circle, hollow circle. We will not at 3 we will be taking a open interval. So our point will be minus infinity to 3 union 5 to infinity. So let's see a few questions, then I will summarize what the wavy curve method suggests. Okay. Next equation we are having, next equation we are having x into x square minus 4 less or equals to 0. So the wavy curve method says that whatever expression you are having, whatever inequality you are having, first factorize it. So first we will be factorizing it. X plus 2, x minus 2 less or equals to 0. After factorizing, just draw the real line, minus infinity plus infinity. Locate your critical point. So here we can see our critical point is 0, minus 2 plus 2. So critical point is 0, minus 2 plus 2. Here how many parts we are getting, how many intervals, minus infinity to minus 2, minus 2 to 0, 0 to 2, 2 to infinity. Now which one will be the solution for the given inequality? So from the right hand side we will be placing plus sign, then minus sign, then plus sign, then minus sign. Okay, where we have to avoid this, where we are going to be careful, that also I will be letting you know. Just be with me for a while. So here what the expression says, here the expression is demanding about, just see this yellow line, underlined part, x plus 2, x minus 2 must be smaller than and equals to 0. Smaller than 0 means negative we want. And equality sign is also there. So this hollow circle, this here we will be, previously we have taken hollow circle, here we will be taking the solid circle. Here also we will be taking the solid circle. Okay. And 0 also solid circle. Now which one is the interval we are having over here? So see carefully. Our interval will be less or equals to 0. That means minus infinity to minus 2. But with minus 2, I will be making a closed interval because it must touch minus 2. Okay, because there is equality sign also. After that, the another interval where we are having negative is 0 to 2. So 0 to 2 union. This is how quickly, without taking the test point, we are writing the intervals. We just have to be careful. We just have to be careful in the first inequality, in the second inequality. We just have to be careful that first we will be having a factorized form. Okay. One more thing we have to be careful, that we will be seeing in the next inequality. And our next inequality is 2 minus x minus 5 is greater than 0. Now wavy curve method says that every term must be factorized, but one more condition is there, x must be positive. In each and every factorized form, x must be positive. So here x was positive. We have directly made the number line, and just from the right we have written plus minus like that. Another one, We have just done the factorization. After factorization also x was positive. That's why we have just gone ahead and we have repeated the same process. So first thing first, wavy curve method says write the factorized form. Always we must have the factorized form. The next step must be x must be positive, or coefficient of x must be positive. Coefficient of x must be positive. So if we are having an equation like this, what we have to do at first, we have to multiply minus on both sides. Now, if you have learned the concept of inequality very well, you should know that here we will be multiplying minus, there also we will be multiplying minus, then this sign of inequality will reverse. This sign will become that sign. It will just reverse to this way. Is like this concept is known to you or not? Whenever
Yes.
we do the multiplication of negative in any inequality, then we have to reverse the sign at the same step. Is it known to you? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, this one is known to you. So we are multiplying negative on both the side. Other side will just remain 0. In this side, we will be having x minus 2, x minus 5. Why we did so? So that we can go ahead and we can use the wavy curve method, which says that all the factorized form we must be having and the coefficient of x must be positive. Okay, so now we are having a number line minus infinity plus infinity. Critical point, just put it 2 and 5 from the right hand side. Just start writing plus, then minus, then plus. What we need, what will be the solution set? We need x minus 2, x minus 5 is smaller than 0, lesser than 0. That means negative we need. Okay, so negative, we will be focusing on the negative over here. That means this interval only less than 0 is there. Equality sign is not there. So we will be having 2 to 5 open interval. Is it clear? Now next example I would take, which is also related to wavy curve method. So the next example is, with the help of example, we are learning what we need to avoid and where we have to be careful while using the wavy curve method. Okay, so the next one we are having, let's say, suppose your equation inequality is like this: x plus 2, x minus 1 whole square, x minus 5 greater or equals to 0. Now here directly if you will go and will apply the wavy curve method, it will fail. Why? Because due to this power 2. Okay, so what we have to do for such condition, we will be locating our critical point, negative infinity, positive infinity. Critical points are negative 2, positive 1, positive 5. Negative 2, positive 1, positive 5. Okay, now the solution, in actual you will be getting the solution over here as, you will be getting like this. When you will take the test point and then when you will start checking, then this is what you will be getting. Now wavy curve method failed. What I said, plus then minus then plus then minus, we will change the sign and we will get the interval. So what also we have to keep in mind, when we are using wavy curve method, the powers of all the factorized form must be odd power. Whenever we are having this type of even power 2, 4, 6, 8, then what we will do, let's see. Then first, on the very right hand side, on the very last part of the interval, we will be writing plus sign. Okay, after that we are going to shift. This 5 is the critical point. It came from where? It came from this factorized form. What is the power of it? Is it odd or even? Is it odd or even?
Odd.
It's odd power. Whenever the factorized form is having odd power, there will be change in sign. So if you have written plus, there will be minus after that. We have written minus after that. Now we just go on to the next critical point, that is 1. This 1 came from where? This 1 came from this factorized form. What is the power of that factorized form? Is it even or odd? So this is even. This 2 is even. Whenever we are going from even fact, whenever we are having the critical point from even, uh, whenever we are having a factorized form and that's power is even, then when we will jump to the next interval, the sign will not change. So this minus will remain minus only. If you are still getting confused, don't worry. At last, this concept will be very simple for you. I will summarize everything all together. Okay. So when we are going from even, then there will be no change in sign. This minus sign will remain minus. Now we have gone to the next critical point, that is -2. From where we got this -2? We got from this part. What is the power of this factorized form? The power is odd. Hence, there will be change in sign. And this is the solution set. We will be getting this solution set by taking test point, like first test point from the first interval, test point from the second interval, test point from the third interval, like that. And that will take a lot of time. Okay. So at last, what we have to what we need to take, the positive one or the negative one. So see, this one must be greater than equals to 0, greater than and equals to 0. Greater than means we need to take the positive one, and equals to 0, that means the solid circle, the solid circle, the solid circle. Okay, so we will be taking the interval which is having greater than, that means minus infinity to 2. We will also be taking 5 to infinity. And we will also be taking this 1, which that is also making it equals to 0. Greater or equals to 0 is there. So we will be taking this 1 also. So this union, this 0.1. Okay. Now the next question where we will be using all the conditions. So let me write the steps. Wavy curve method suggests that we must have factorized form. Previously, why we have not just checked the power? Because here all the powers are odd. Odd power, odd power. That's why whenever we have jumped, we have changed the sign. Again jumped, again changed the sign. Here also we were having odd power, odd power, odd power. When we will be having critical point that came from odd power factorized form, then we will change the sign. And if it came from the even power, we will not change the sign. Whenever we are jumping to the other interval, we will always start from the right hand side. Okay. So first thing first, factorized form, next coefficient of x must be positive. Third, check the exponent of factorized form while jumping from one interval to other, and then at last just select the, be careful with the hollow and solid circle. If there is equality sign, we need to take those points. Now the next question is,
Which chapter is it?
yeah, what?
This which chapter is it? I was out for 10 minutes.
Can you please repeat?
Like which chapter are you doing, ma'am?
We are doing relations. Sets
Okay.
we have covered, relation we have taken. One example we have solved over here. The second example we will be doing just now. In between that, we were discussing the concept of wavy curve method. That concept is related to solving the inequality. Now this inequality, every time we will be getting it while solving the question of function, while solving the question of relation, or while solving any other concept from our JEE syllabus. We will be getting inequality that we need to solve very quickly. So we must know the concept of wavy curve method. Okay.
Okay.
For applying the wavy curve method, these are the few steps which I have written. Quickly we will be writing plus minus plus, but we have to be careful that our factorized form must be there, coefficient of x must be positive over there, and the exponent, when we are switching the exponent, if it is linear, x minus 1, x minus 2, x minus 3, just like that, then plus minus we can write. But if we are having x minus 1 whole square, x minus 1 to the power 4, if we are having such factorized form and from there we have taken the critical point, then we have to be careful when we are jumping the interval from one interval to another interval. When we are going, then we have to see if the power is even, then no change in sign will occur. And if the power is odd, then we will change the sign. Let's apply these concepts in our question. So we have to find the domain of this function. F of x equals to sine inverse this, cos inverse this. Now inverse trigonometric function you have done, and you know that sine inverse, this input, what is the domain of sine inverse function? Anyone?
Minus 1 to 1 in a closed interval.
Close interval minus 1 to 1. Cos inverse also close interval minus 1 to 1. That means whatever is here, that must lie in between minus 1 to 1, right? So whatever is
On the
written in,
input.
yeah, whatever is there as an input of sine inverse x, that must lie in between minus 1 to 1, right? And that the same with cos inverse also. So let's write it. We are having sine
Can you
inverse.
scroll up?
Yeah, sure.
Just show the question.
Can we move ahead?
Done, ma'am.
Okay. So let me take the question. Sine inverse 3x square. What is that? 3x square plus x minus 1 over x minus 1 whole square. Okay, this, the inside function, the inside rational part, that must lie in between negative 1, close interval, you only said. So equality sign also I am taking, 3x square plus x minus 1 over x minus 1 whole square. Here also it will, there will be 1 and equality sign also be there. Let's solve it. So we can multiply both side by x minus 1 whole square. Is that allowed in inequality? No, that is not allowed in inequality. When we are solving inequality, then if we are multiplying with negative or dividing by negative, we have to reverse the sign. But just focus on this one. Just focus on this term. Whatever be the x value, this total will generate a positive output only. X minus 1 whole square will always be positive. And that's why I am saying that multiply each and every part by x minus 1 whole square. And we will not change the inequality sign. We will just repeat the same inequality sign. Why? Because it's a positive. Okay. When we are not sure whether it will be positive or negative, it depends on the value of x, then we will not multiply like that. And if we will multiply like that, we will think about the changing the inequality sign. So here we are multiplying all the part by x minus 1 whole square and not changing the inequality sign. Why? Because it will generate a positive output. 3x square plus x plus 1. Here also we will multiply. Oh, okay, here we have multiplied and the denominator gone. X minus 1 whole square. Is it clear so far? Is it clear so far?
Yes, ma'am.
Let's solve it quickly. We are having this one inequality, another inequality, we will be solving it part by part. Okay, so that confusion will not arise. So minus x minus 1 whole square. Quickly, let's do it. 3x square plus x plus 1 we were having, no? Yeah. Plus 1 or minus 1? Minus 1. Minus 1. And the other one is 3x square plus x minus 1 less or equals to x minus 1 whole square. Let's do it. So we will be having minus of a square plus minus 2ab plus b square less or equals to 3x square plus x minus 1. So we will be having minus x square over here plus 2x over here minus 1 over here. We'll be having 3x square over here plus x over here minus 1 over here. I can see minus 1 will cancel out each other, and we will be having 3x square plus x square, that is 4x square. We are just solving the equation quickly, and 2x over here will go to other side, so minus x will be there, that will be greater or equals to 0. So we can write 4x square minus x greater or equals to 0. We are just going to use the wavy curve method but factorized form. So x we will take out common, here we will be having 4x, here we will be having minus 1 greater or equals to 0. What the wavy curve method says, all the term must be the factorized form, and we must be having x as a positive. The coefficient of x must be positive, then only we can go ahead. Number line we are drawing, we will be locating our critical point. So we are getting 0 over here and we are getting 1 by 4 over here. Clear so far? Is it clear so far?
Yes, ma'am.
Now, wavy
Yes,
curve
ma'am.
method said from the right start. Plus, if the power is odd, change the sign. From where this 1 by 4 came? It came from this factorized form. If this one's power is odd or even, its power is odd. If its power is odd, we will change the sign, minus. Now we just reach to the next critical point, that is 0. From where it came? It came from here. What is the power of x? Is it odd or even? It's odd. We will change the sign, plus. Now what we need to take the solution set, it must be greater or equals to 0. Greater or equals to 0. That means equality sign is there, solid circle. Greater than, that means plus we will be taking. So we will be taking solid circle because equality sign is there, and greater than means we will be taking the positive part only. Negative infinity to 0 we will be taking. Okay, close interval 0. Union 1 by 4 to positive infinity. This is our solution set. Is it clear?
Yes,
Is it
ma'am.
clear
Like
to everyone?
it should be minus 1 to 1, right?
It will be?
I mean, the domain should be minus 1 to 1, right? Like it's infinity.
Yeah. But the final domain we need to find, no? Sine inverse
Oh, yes, yes,
function's
ma'am.
domain is minus 1 to 1, but the given function is, can you see, it's not just sine inverse of x. That's why the input, this total inside the bracket, we are assuming it as x, and we are just comparing it with, it will lie in between -1 to +1. Okay? And that's
Yes.
what we have solved over here. From there we got to inequality. We are trying to solve both the inequality. First we have solved already. Second we will be solving. So this and this also we need to solve. Let's solve it quickly. So we will be having 3x square plus x minus 1 less or equals to, here a square minus 2ab plus b square. So 3x square minus x square will be 2x square plus x, and here minus 2x, it will be plus 3x, and here this minus 2 less or equals to 0. So 2 times 4, now we have to split the middle term, we have to do the factorization. 4 into 1 we will be doing it. So 4x minus x, we will be writing it 2x square plus 4x minus x minus 2 less or equals to 0. Here we will be taking out common, we will be getting 2 bracket less or equals to 0. The first bracket will have 2x plus 2. wait, 2x if we will take common, it will come out as a x plus 2. And here minus 1 we will be taking common. Check it. This is what we are getting, yes or no?
Yes.
Now again wavy curve method. But be careful. All the form are factorized form. Yes. X coefficient of x is positive over here. Yes.
It will be positive, negative.
Yeah. It must not be negative. If it is negative, then we will multiply negative sign in both the side and will change the inequality sign. Reverse the inequality sign. So negative infinity, positive infinity. Now critical point 1 by 2. Critical point negative 2. Now just start from the right hand side and start writing the sign. So at first we will be writing plus sign, and then we just reached at 1 by 2. From where it came from here. Power is odd or even, its power is odd. So we have to change the sign, and we got the interval. We need less or equals to 0. So less this one and this one. Negative 1 we will be taking. So the interval will be -2 to 1 by 2. This 2 we got, this 2 are AND case. That means intersection we need to take from these two cases. The same inequality we have solved, this, and we got this solution and this solution. So we need to take the intersection of these two solutions. Okay. Let's take the intersection. Let's locate all the points. Negative infinity is 0. Positive infinity, we are having 0. We are having -2. We are having 1 by 4 and 1 by 2 also. We have located all the critical point. Now the solution set we will be finding. We need to take the intersection of this solution and this solution. The common region which will come in both. So this one is negative infinity to 0. Negative infinity and 0. So it will go like this. Okay. 0 close interval. 1 by 4 to infinity. 1 by 4 to infinity. This is one of the solution. The another solution I am just locating downside, and we will be taking the intersection. -2 closed to 1 by 2. 1 by 2 closed. What is the common reason? Can you see this one is the common part? This much and this much.
Yes,
Can
ma'am.
you see it? Yes or no?
Yes, ma'am.
Yes, ma'am.
So our solution of both the intersection of both the solution will be -2 close interval of course to 0 union 1 by 4 close interval to 1 by 2. This is the solution set we got from the sine inverse case. Okay. Similarly, we will be getting from the cos inverse case, but cos inverse will be easier. Can you see it is just x minus 1 by x plus 1. That also we will compare with -1 to 1. Let's do it. Cos inverse is also given over here. So we need to take the final solution set, which will be valid for the sine inverse also and the cos inverse also. We are having the other function as a cos inverse. It was x minus 1 by x plus 1, right? Yeah, x minus 1 by x plus 1. Once you are able to understand this question, then a lot of question you will be able to do, which is based on wavy curve, which is just based on very smaller function will be there, inside function will be there, that we just need to solve by using the inequality. Let's do it. So x minus 1 by x plus 1, this is greater or equals to -1, lesser or equals to 1. Okay, now we just need to solve it. If we will be subtracting 1 from here and from here also, subtraction, addition, everything is allowed in inequality. Okay, we don't have to worry about the sign of inequality. So here we will be having x minus 1 minus x minus 1. Okay, in denominator we are having x plus 1. Why we have subtracted minus 1? So that x and x will cancel out each other. Either x will be there in the numerator, that will be fine for us, or x will be there in the denominator, that will work for us. Numerator is also having x, denominator is also having. We have to think about something, how to eliminate numerators x or maybe denominators x. Okay, by adding, subtracting, multiplying, division, rationalizing, whatever works, do it. So less or equals to 0. So what we got? Minus 2 less or equals to minus 2 by x plus 1 less or equals to 0. Now here, if we will divide all the sides by minus 2, this minus 2 will go. But when we are dividing all the sides by minus 2, we have to reverse the inequality sign. This is where we have to be careful. Okay, 0 by minus 2 will be 0 only. So we are getting 1 greater or equals to 1 by x plus 1 greater or equals to 0. Now I want to write the reciprocal on all the sides. Is that allowed in inequality? If 2 is greater than 1, then 1 by 2 is also greater than 1. Is it so?
No,
No,
ma'am.
ma'am.
That means we have to reverse the inequality sign if we are thinking about writing the reciprocal. Yes or no?
Yes, ma'am.
If we are thinking about writing the reciprocal, we have to reverse again the inequality sign. So this will become 1 by 1, 1. And this will become, here in the denominator, what is there? It will become 0, 0 by 1 is there. So 1 by 0, that means infinity will come. So whenever we are having infinity in mathematics, we don't use the equality sign. Can you see? Equality sign we don't use when we are having infinity. Okay?
It's
Because
an
we are
open
not
interval,
able
right?
to touch the infinity.
So less than sign only.
Yeah, what?
Less than sign only.
Yeah. Can you please repeat? Are you asking something? Okay. Now you are
I was
having
saying
online
like
class
only
also.
less than
Okay,
sign
let's
is there,
wrap
right?
it up. Okay, we got the interval over here. Now we will be finding the common interval of this one and the solution set which we have found over here. Again, we are able to get the interval over here. Once we will be subtracting minus 1 on all the part, we will be getting the range of x, that is here 0, here infinity minus 1 will be infinity only. So 0 to infinity we got, and previously we are already having this solution set. Now the common solution set will be our answer. So do it as the last part as a homework. Okay.
Yeah, can you just put this?
Yes, just see the
Scroll
question.
down.
Scroll up or scroll down.
Scroll down, ma'am. I just wanted to see the graph.
This one done.
A little more. Can you scroll down?
More.
Yes, ma'am.
This
Here, ma'am.
one.
Now little up, ma'am. Yes, on this one.
Take the screenshot, write the solution, whatever you can do, do it. But write the question also. The last part I am leaving for you. Write the, take it out the common interval, the common solution set, which we are getting from both the set. Once you are able to understand this question, you will be able to do a lot of questions like this. That's why I have taken this question. I believe the wavy curve method is also clear to you. Next step, we'll be taking the next topic. And if you will be having any doubt, that also I'll be taking. Take the screenshot if you want to take. And yes,
Done, ma'am.
skipping it this much,